everyone, welcome back to Diksha Karnataka YouTube channel, and in the Sankalp KCET 2026 series we are discussing the most important chapter for KCET, that is current electricity. We have already covered the theory part, important formulas and equations from the chapter in the two-part video. If you have not seen that, you can go back to our channel, find the physics Sankalp playlist and you can watch that. Also, we are covering each and every chapter one by one. The next chapter after current electricity will be ray optics, because I know some of you have after current electricity, maybe next chapter is not yet started, or even if it is started in your FA1, that is your formulative assessment 1, you have ray optics as well. So we will be discussing ray optics as well after this chapter is over. So ray optics and wave optics we will do, and then we will come back again from moving charges and magnetism chapter onward. Okay, so for now this is the last chapter of the book 1 of your PU1 PU2 right, and today I am going to discuss the very important KCET previous year questions from this chapter, and every year 5, 6, even 7 question can come from this chapter. My expected question number of questions from this chapter is 5, so watch very carefully. This is the most important chapter for your KCET. Right now, before going into the discussion, I want to request you to join our WhatsApp channel. The link of the WhatsApp channel is given in the description. There you will get all the new stuff that we are doing. So we have done Menti quiz. If you missed that out because you are not part of our WhatsApp channel, so Menti quiz is something exciting that we are doing live, and also we will be doing more new things. So for that you have to join our WhatsApp channel, and also you will get the link for the class notes including the solution of today's question, today's all the detailed solution, right? And these students, they have joined our WhatsApp channel, they have followed our channel, they have subscribed to our channel from the beginning, and they are featuring here for this year's leaderboard. Prajwal, Diksha, Kiran, Samiksha and Sachin. Also we have many more names. We cannot take all the names of the toppers. So many toppers are here. We did a very long beautiful video, and next year maybe it is your name and your picture that will feature in our video. So if you want that, you have to follow our channel and follow all the lectures, follow all the instructions that we are doing, because we have achieved this through YouTube only. These students are our YouTube students, and we do not know their faces until we meet them at the meet and greet function that happened in our office few months back. So obviously your face is also unknown to us, and I want to meet you. For that, what you have to do, you have to achieve a beautiful rank in KCET 2026 exam, and then your picture and your name will be featured on our video exclusively, right? And now without any delay, let's start with today's lecture. First question is coming up, and this is from the year 2025. So exactly this year, whatever KCET exam happened in April, from there we have taken this question. In the following circuit, the terminal voltage across the cell is. Now just pardon me for the slightly poor quality of the picture, because obviously it is taken directly from the question paper. We do not have any printed question available as of now, so that's why, but I think you can see this picture clearly without much issue, right? So here we have a battery, we have a resistance of 3.9 ohm and another internal resistance of the battery, that is 0.1 ohm. So whenever you see a circuit diagram like this, you will know that this resistance is nothing but the internal resistance, and we have a 2-volt cell. So they asked you in the following circuit the terminal voltage across the cell. So terminal voltage means terminal voltage you always calculate from these 2 points. So what is the formula? If you remember, the formula is very simple. V is equal to epsilon minus I into R. So that was the formula for terminal voltage. We discussed it in our last class. Now how to calculate I? To calculate I, we have to calculate epsilon divided by capital R plus small r. right? These are the formulas. So epsilon is given as 2 volt, R is given as 3.9 and small r is given as 0.1. So it will be 2 divided by 4, that is 0.5. Right, now you have to put this value in this equation. Epsilon is 2 minus I is 0.5 and the internal resistance is 0.1, so it will be 1.95. okay, 0.5 into 0.1 is 0.05, so 0.05, 2 minus 0.05 is 1.95. so correct answer is this, option A is correct. Next question, two cells of EMF E1 and E2 and internal resistances R1 and R2. Here it is given that E2 is greater than E1 and R2 is also greater than R1. Okay, respectively are connected in parallel as shown in the figure. The equivalent EMF of the combination EQ is, then there are few conditions that you have to find. Now this is a very unique question and you cannot solve this question directly. For that you have to assume some values, very important, and it is very essential. In some cases we assume the values in some questions. For example, here it is mentioned that E2 is greater than E1. So suppose we say E1 is 1 volt. We can take any values as long as E2's value is greater than E1. So we take E2 as 2 volt. Very simple numbers. You can take any simple numbers. Okay, does not matter as long as they are real numbers and as long as they are non-zero numbers. You can take any real numbers. I am taking the smallest possible numbers, 1 and 2. Easiest possible thing. Also R1 I am assuming 1. R2 also I am assuming 2. Because R2 is also greater than R1. So both conditions are satisfied in this case, and we will try to find the equivalent EMF and then we will see which of the following condition is met. You cannot do it theoretically. If you try to do it theoretically, it will be very long and you will not be able to understand which of the combination is correct, right? So before discussing the options, let me solve, because they asked you about the equivalent EMF. Now we know that for parallel combination of cells, equivalent EMF divided by equivalent resistance equals to E1 by R1 plus E2 by R2. This is the easiest formula I told you to remember, right? Now what is Req over here? Req is R1 R2, because only two resistances are there, so it will be R1 R2 plus R1 plus R2. Parallel combination, right? Parallel combination of resistance, only two resistances are there, so this is how you can calculate. So we know that 1 into 2 divided by 1 plus 2, that is 2 by 3. 2 by 3 is the equivalent resistance. Now go back to the original equation, that is epsilon equivalent by R equivalent equals to 1 by 1 plus 2 by 2. That is why I choose them 1 1 2 2, so that 1 by 1 is 1, 2 by 2 is also 1, does not matter. So you get 1 plus 1, that is 2. So you get EEQ equals to 2REQ. Now what is REQ? REQ is 2 by 3, so multiplied by 2 by 3, so you get 4 by 3, that is 1.33. Okay, 4 by 3 is 1.33. Now let's see which of the conditions can be correct. So EEQ is greater than E2. EEQ, is it greater than E2? That is 2. E2 is 2. Is it greater? Obviously not. EEQ is less than E1. Is it less than 1? No. So these two statements are incorrect. E1 is less than EQ, but it is also less than E2. That means E1 is less than EQ and EQ is less than E2. So E1 is less than EQ. Is it correct? E1 is less than EQ. Yes, it is correct. And it is less than E2 as well. It is less than E2 as well. So this, either of these two options will be correct. Now there is another option added to this, and E equivalent is nearer to E1. E equivalent is nearer to E2. Now that is the condition. So obviously one of them will be correct, both of the options are also correct, and if you want to guess the option, you have to always check, okay, these two options are matching, that means one of them will be correct. Only this condition I have to verify. This is also another way to understand. Now if you see that 1.33 is 0.33 more than 1 but 0.67 less than 2. Clear? 1.33 is greater than 1 by 0.33 and it is less than 2 by 0.67. Now which number is bigger? 0.67 is bigger than 0.33. So obviously the equivalent EMF is nearer to E1. It is nearer to E1. Okay, so this condition is true and E equivalent is nearer to E1. If you found that this number is 1.5 or more, if the number is 1.51, 1.52 or 1.6 like that, then it would be closer to E2. Okay, and it does not matter whatever combination you have chosen, it is independent of the combination, because you can check any other values, say 100 volt, 100 ohm resistance or 1 ohm resistance, you will always find this result. Okay, so equivalent resistance is always closer to the smallest resistance, smallest EMF. Equivalent EMF is always closer to the smallest EMF, in case this is the condition. If resistance is also small, then this is the condition that you have to remember. In other case, if they reverse the resistance order, then you have to solve it like this way only. This is the only way to solve such question. Okay, even though the values are not given, you have to identify the values, you have to give the values yourself and solve it as a problem and then check which option is correct. The variations of resistivity rho with absolute temperature T for 3 different materials X, Y, Z are shown in the graph below. Identify the materials X, Y and Z. So here you can see there are 3 materials X, Y and Z. Now let's see what are the materials. X semiconductor, Y nichrome, Z copper. So we have semiconductor, nichrome and copper in all the options. Now let us come back to our figure and identify one by one. So nichrome is a material which has a fixed resistivity. Okay, I missed that during our regular lecture. Okay, don't worry, we will cover it in our future videos. Nichrome is a material having almost fixed resistivity. Okay, its resistivity varies very less with time and it is also linearly varies with time. So obviously Y is our nichrome. Okay, nichrome. Copper is a conductor and its resistivity varies, increases with temperature. So as the temperature increases, its resistivity also increases. Resistivity is here rho. Okay, rho. So as the temperature increases, resistivity also increases. So this must be copper. And for semiconductor is a weird device. We have not discussed in detail about semiconductors. We discussed in the first chapter, if you remember. Semiconductors are the materials whose resistance decreases with increase in temperature. Resistance increases means resistivity also, resistance decreases. Semiconductor resistance decreases. So resistivity will also decrease, right? So this is our semiconductor. Okay, so X is copper, Y is nichrome and Z is semiconductor. So we have identified. Now go back to our options. X is copper, Y is nichrome, Z is semiconductor. Any two of them if you get correct, then third one will obviously be correct. So don't worry about it, right? Now next question. Given again, these are all questions are from 2025. Given a current carrying wire of non-uniform cross section, which of the following is constant through the length of the wire? So we have a non-uniform cross section. Non-uniform cross section means the one end of the wire is a little bit smaller, another wire, end is maybe slightly bigger. Okay, it can be reverse also. So non-uniform means it is not uniform. It can be like this way also. Okay, not necessarily it will be like this, it can be like this way also. So non-uniform means as you can see here the area is more, here the area is small. So these are all called non-uniform cross sections. Okay, now in all cases you have to understand that current is given by NEA VD. Okay, so current depends on area, also depends on VD, but the multiplication of A into VD is constant. Multiplication of A into VD is constant. It's similar to that of the continuity equation that you studied in fluid mechanics chapter. A into VD is always constant. Okay, from that fact number density is constant, charge of an electron is constant, so current will be the constant. Drift velocity depends on the cross section always. Okay, so drift velocity will change, only current will remain constant. Only current will remain constant. Now next question, the graph between variation of resistance of a metal wire as a function of its diameter, keeping other parameters like length, temperature constant is. So here we have resistance and diameter, relationship between resistance and diameter, keeping all other factors constant. So we know that resistance is inversely proportional to area of the cross section. Now if you consider a circular cross section, what is the area? Area will be pi d square by 4. Okay, area is pi r square, that is pi d square by 4, right? So let me write that over here, 1 by pi d square by 4, so pi by 4 d square, right? So d square, pi by 4 is constant, so we can say that resistance is basically proportional to 1 upon d square. So it is a inverse square relation. Inverse square relation, if the relationship is inverse square, then what is the type of graph? We have studied that in electric field the graph looks like this. This is the inverse square relation, so this will be the answer. So if you increase the diameter, keep on increasing the diameter, the resistance will slowly decrease and slowly goes to 0. Okay, next question. This is from 2024. So as you can see, in 2025 there are 5 questions that directly came from current electricity. There was one more question which was asked from current electricity, but that was a practical question. Okay, experiment based question. That's why I am not included in this discussion. Later on in future when we discuss experiment based questions, that time I will include that question as well. Right, now let's see question number 6 from KCET 2024. And also some questions in 2024 also, and in the future years also, there are a few questions which were actually out of syllabus. That questions I have, those questions particularly I have excluded from today's PYQ session. So if you see any questions which are not discussed in this session today, that means you can safely assume those are out of syllabus question. Okay, I know many students, those who don't follow my lecture from the beginning, they will come to me and during my live they will say, sir, you have not done color code, is it part of the syllabus or not? Sir, I am confused. Color code are not part of the syllabus, meter bridge are not part of the syllabus, there are many other things which are not part of the syllabus. For that you have to follow my lecture properly, especially the previous year questions. So whatever is excluded, I am not including them in the previous year question section. Okay, maybe some concepts I intentionally kept distant from you right now because you will be overwhelmed, you might find it is very difficult to understand right now. Some concept maybe we will discuss it in future videos, but other than that, all the concepts that we are discussing in the lecture, they are 100% part of the syllabus, first of all. Second of all, in previous year question, I know many of you already have previous year question books, and there you are seeing the questions and you are feeling that sir is not discussing this question, I am facing difficulty in that question. That means 99.99% time that question is out of syllabus. 0.101% of the time the question may be very easy, that's why I choose to skip that. There are also 0.01% chance. Electric field E is electric field inside a conductor whose material has conductivity sigma and resistivity rho. The current density inside the conductor is J, the correct form of Ohm's law. Now, in terms of Ohm's law, we know that J equals to sigma E. If you remember, we have done this mini derivation, right? J equals to sigma into E. Now, if you see, none of the option is given J is equal to sigma E. Many students tend to feel that this is the correct answer. This is not the correct answer. As you can see, there is sigma J is given, but sigma E is not given. So, what is the other options? Let me see that this is also not correct, right? These two are not correct because either J equals to sigma E or J E equals to not J E sigma E. So, one of the other option must be correct. Let's see this option. E equals to J by sigma, right? J by sigma. Now, what is 1 by sigma? Sigma is conductivity. So, 1 by sigma is resistivity. 1 by sigma is resistivity. So, let's put that over here. We get rho J. So, electric field is equals to rho J. So, electric field is equals to rho J. So, this is our correct answer. So, it's the same question, just they have asked it a different way. Now, this question I have solved during my live lecture. If you missed it out, you can check that out. I will solve it once more. This structure is a Wheatstone bridge. This structure, this specific structure where one resistance is drawn, another resistance is drawn like this is a Wheatstone bridge structure, and you have to check if it is a balanced Wheatstone bridge or not. So, if you see that R by R is 1, R by R is also 1. So, is this equal? So, R by R equals to 1 equals to R by R. That means the bridge is balanced. If this by this equals to this by this, then the bridge must be balanced, and if the bridge is balanced, then we can simply ignore the central resistance. Okay, you just have to erase it from the circuit, and once we erase it, that means only what we are left with is there is one resistance, second resistance, they are in series, and there is one resistance, second resistance, they are in series, and this combination is in parallel. So, once you erase it, what you get, the circuit looks like this, right? One resistance, two resistance, another resistance, and this is how the circuit looks, right? RR, RR. If you redraw this circuit, redraw them like this, okay, then you will get this. So, 2R plus R, 2R, because they are in series combination, right? R plus R is 2R. So, what we get? We get a 2R over here, and similarly here also we get R plus R, 2R. Now, this 2R and 2R are in parallel combination. Now, if two equal resistances are in parallel combination, their equivalent resistance is given by the equal value of resistance divided by number of resistance. If the equal number of resistances are connected in parallel, then any one of the resistance divided by total number of resistance gives you the equivalent resistance. In this case, only two of them are there, so equivalent resistance is R. So, here as you can see, this is a Wheatstone bridge having all the resistance R, and their equivalent resistance is also R, correct? Now, here also you will see that this is also another Wheatstone bridge, okay, 2R, 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 right? So, again we can ignore the central resistance in this part as well. This is second Wheatstone bridge, so we just need to ignore this second Wheatstone bridge central resistance. Again we will get the similar structure. Now, from the similarity, that if everything is R, the equivalent resistance becomes R. So, everything is 2R, that means equivalent resistance will be 2R, right? We don't need to do the mathematics once more because we have done it once. That means second one also we can simplify it easily. So, what is the total resistance? Now, this is R and this is 2R, right? So, they are now connected in series. This is point A, this is point B. So, what is the total resistance? Total resistance is given by R plus 2R, that is 3R. So, this is the 3R. Now, if you apply voltage V0, then what will be the current? Current equals to V0 divided by total resistance, that is V naught by 3R. So it will be V naught by 3R, that is the current in the circuit. Simple question, don't get afraid seeing the circuit itself. Now it's another good question. The electric current flowing through a given conductor varies with time as shown in the graph below. Okay, through a given cross section with the conductor and time. So the number of free electrons which flow through a given cross section of the conductor in time interval 0 to 20. So from 0 till 20, how much electron is flowing, not the charge, very important, not the amount of charge but number of electron flowing during this time. So first we have to understand that what is the current is given by charge by time. So charge is basically given by I into time. Okay, now if you draw I versus time graph, then charge will be the area under the graph. I into T. How to do I into T? Basically it is an integration, but I don't want to make this complicated, because the integration is basically gives you the area under the graph. So this is the area under the graph, so that will give you the charge, not the electrons, by the way. So how to find the electrons? To find the electrons you have to use quantization, that is equals to N into E. From there we can find the number of electrons will be IT, or total sum of IT divided by E. Sum of IT means basically area under the graph. Okay, now we have to find the area under the graph of this little shape. Right, now if you see that this is a trapezium, right, this part is a trapezium and this is a rectangle, this is a trapezium. Now what is the area of a trapezium? Some people might say that, sir, this is a triangle, this is a rectangle and this is another rectangle. That will be a longer process but correct. But I want to use a little shortcut method, that I will consider this kind of shapes always, I consider them as trapezium. It is very good to know the formula for trapezium, that might save some time. So what is the sum of IT? Sum of IT means this area plus this area, area 1 and area 2. Now what is area 1? Trapezium. Area 1 is a trapezium. Trapezium's area is half into sum of the parallel sides. So what is this, by the way? If you observe this graph, you will see that this is starting from 0, this is going to 200. So what is between 0 and 200? Must be half. This is half point, so this must be 100. Now this is going from 200 till 400. So what is the midpoint? The midpoint will be 300. So these are not given, but you have to identify those points. Okay, so this is how you read the graph, right? So 0 to 200 is this point. So that means the midpoint between them must be 100. So parallel side means this 100 side plus this 300 side. Okay, clear? 100 plus 300, because parallel sides are along y-axis, right? This length is 0 to 100, that is 100, and this is 0 to 300, that is 300. Times half into sum of the parallel sides plus the distance between the sides. Now what is the distance here? 0 to 10, that means distance is 10, right? So distance is 10, right? So this is how we calculate the first area. Now second area is easy. This is a rectangle. So what is the second area? Second area will be plus, obviously they are getting added, same side. So plus length into breadth. Length is 300 and breadth or width is 10 to 20. 10 to 20 means the width is 10, 20 minus 10, that is 10, right? So this is how you calculate the area. So half into 400 into 10 plus 3000 equals to 200, that is 2000 plus 3000, that is 5000. Now this is milliampere. The current in this case is given in milliampere, very important. So this will be milliampere second, because you multiply with time, that means it is 5000 milliampere second. But we always try to convert it into ampere, that means it will be 5 ampere second. 5 ampere second, or coulomb. Okay, you can say this is coulomb. Ampere second is basically coulomb. Okay, so 5 coulomb. So charge is 5 coulomb or 5 ampere second. Now this is the charge. You have to convert it into number of electrons, right? So you have to divide it by the charge of an electron, or I told you a shortcut. I told you a shortcut to convert any charge into number of electrons directly. How? By multiplying 1 coulomb charge. For 1 coulomb charge, you have to multiply 6.25 into 10 to the power of 18. 6.25 into 10 to the power of 18. Now what is this value? 5 6 ja 30, 5 6 ja 30, 30 and 5 25s are 125, so it will be 31.25. 31.25. You have to multiply these easy multiplications without using a calculator. And if you are confused, sir, in any sense I will not be able to multiply it like the way you are doing, then there is a simpler way as well. What is the simpler way? Just ignore the 0.25 for now, ignore the 0.25, multiply 5 into 6, 5 6 are 30, right? 30 into 10 to the power of 18. Now if you see 10 to the power of 18 options are completely different, so let's convert it into 10 to the power of 19. So 3 into 10 to the power of 19. Now see which of the answer is closest. So as you can see, this is the closest answer. This is the closest answer. Option A is correct in this case. Okay, so this is how you learn how to do problems faster in shortcut. Okay, this multiplication, and always stop using your calculator right now. The calculator, you might think that I am saving some time, but you are doing more harm than anyone else. Also, as if you remember yesterday I told you, your fight is with yourself only, and if you start losing your hope and if you just put your book down, then you are already lost and everyone will defeat you. The only way you will get defeated by only you. Okay, so don't feel down. You have to courage up and you have to say, I can do it. Write down on your wall or your book that I can do it. I can also do it. You will do it. I know, I have that confidence in you that someday you will come up and you will say, sir, because of you I have done that, right? So I know questions obviously will not be straightforward. They will have some one or other trick. Okay, so here we have two graphs. Okay, this angle is, bigger angle is 45 degrees. Hopefully this is visible, and the smaller angle is 30 degrees. The smaller angle is 30 degrees, the bigger angle is 45 degrees. The IV graph for a conductor at two different temperatures, 100 degree and 400 degree, is as shown in the figure. Now they have not mentioned which one is 400, which one is 100. Very interesting, right? Is shown in the figure. The temperature coefficient of resistance of the conductor is about. This is the 2024 question. Slightly tricky question, but not impossible. Okay, if you have understand the concept, if you know the concept, if you have followed my bridge course where I discuss this kind of questions, then you will be able to understand this question. Now, what is the graph? Along y we are plotting I, along x we are plotting v. Now what is the relationship between V and I? V equals to I R. They asked you to find the resistance coefficient. So obviously from this graph somehow we have to calculate the resistance. So what is resistance, by the way? Resistance is given by V by I. V by I, right? So V is along x-axis, I is along y-axis. Now if somehow I can write this as I by V, then what will happen? So 1 by I by V, I can do that, right? 1 by division, so V will go up and the value will remain unchanged. Now what we have achieved by this? Now if you see this denominator now, I by V, what does it represent in respect of this graph? I is along y-axis, V is along x-axis. So you can also write this as delta y by delta x. Because it's a straight line graph, delta y is insignificant, not required, even y by x will do. So what is this? This is nothing but your slope of the graph. This is nothing but slope of the graph. Now what is slope? Slope is tan theta. Slope is tan theta. So now what we have to do? We have to identify the resistances for individual cases. Suppose this resistance, okay, this resistance say 30 degree one say 1 and 45 degree say 2. Just because I know I am doing little bit of cheating over here, okay. So let me name 45 degree as 1, 30 degree as 2. It does not matter, you can name anything, but just for little simplification I am using this, and also as I know the answer, as I told you, I am doing a little bit of cheating over here. Now let's find what is R1. R1 is nothing but 1 by tan 45 degree. Okay, we have already established I by V is tan theta. So what is R1? R1 is for tan 45 and it is given 1 by tan theta. So you can, here you can write this as 1 by tan theta. Okay, 1 by tan theta. So 1 by tan 45 degree, that is obviously 1 by 1, that is 1. And what is R2? R2 is 1 by tan 30. This is 30, the smaller one. So here it will be 1 by root 3, that is root 3, 1.73. 1.73. So now as you can see that this is a bigger value, this is a smaller value. This is a bigger value, this is the smaller value, right? So obviously R1 corresponds to 100 degrees and R2 corresponds to 400 degrees. Now this is not end, you are not only you don't need to identify, you have to find the temperature coefficient. So how to find the temperature coefficient? Temperature coefficient formula we know, alpha equals to the difference in the resistance R2 minus R1 divided by the smaller resistance into difference in the temperature. Difference in the temperature. Okay, this is called the temperature coefficient, right? So R2 is 1.73 minus 1 divided by 1 into 400 minus 100, that is 0.73 divided by 300. Okay, which will be let me calculate, 10 to the power of minus 3, 7.3 by 3. What I have done, again I have taken these two zeros in the 10 to the power. Also I have taken one decimal from this number to shift it by one decimal. Okay, this is a smart mathematics. This is called smart mathematics. Okay, we just want to have some value. That's why it is very difficult sometimes to calculate in decimal, and many students make mistakes. That's why we have simplified it. Okay, so 3 to the 6, 3 to the 6, then we have 13, 3 4 is 12. So 2.4 into 10 to the power of minus 3. 2.4 into 10 to the power of minus 3. Now if you see, none of the answer is actually given here directly matching with this value. If 2 was given in the answer, then 2 would have been the answer, but 2 is not given. What is the closest value given? Closest value given is 3. Okay, so obviously we will choose 3 as our answer. Okay, I hope that clears. Now next question. An electric bulb of 60 watt 120 volt is to be connected to a 220 volt source. What is the resistance should be connected in series with the bulb so that the bulb glows properly? Okay, so as you can see, the voltage of the bulb is 120 volt. The power rating is given 60 watt. So basically what will happen if you connect this bulb without any battery to the source, then the bulb might get fused, because the rating of the voltage rating of the bulb must be same as the supplied voltage. Now as you can see here, the voltage rating is 100 volt less than that of the given source. Okay, given source is 220 and the voltage rating is 120. Okay, so first of all we have to do two things. We have to find the resistance to be connected in series. Now if you connect a resistance say R, then if the bulb is glowing at full capacity, that means exactly 120 volt is across the bulb, right? And the supply is 220 volts, so remaining 100 volt is across the resistance. Remaining 100 volt across the resistance. Okay, so if we can somehow find the current in the circuit, then resistance can be calculated by V by I. Okay, V we already know 100. If we can find I, we can find the resistance. Right? Now how can we find the current I? We can find the current I from this given expression. You don't need to go to resistance calculation, that will be longer and complicated. We just need to calculate the current from this equation directly. What is the formula? The power equals to VI, Vodafone Idea. Energy is vitamin, power is Vodafone Idea. Okay, so I is basically power divided by the voltage. Now here everything will be related to bulb. This is everything related to bulb only. Okay, so what is the power of the bulb? Power of the bulb is 60, voltage of the bulb is 120. So the maximum current that the bulb will allow is half ampere, that is 0.5 ampere. The maximum current will be 0.5 ampere. So put the value now from this voltage analysis. We already know that 120 volt across the bulb means remaining 100 volt must be across the resistance. So voltage across the resistance is 100 volt and current is 0.5. If you don't understand this, watch this part again. If you don't understand this, you have to watch this part again, and once you watch one more time, I hope your doubts will be cleared. Okay, step by step process. Voltage, you have to understand two things. Voltage always distribute across different components, okay, and based on their resistances and the values, the voltage can have different values. Okay, so for example 120, if the bulb is glowing in its full capacity, that means exactly 120 volt should be across the bulb. Now we supply 220 volt. What will happen to the remaining 100 volt? Remaining 100 volt must be dropped across the resistance. Okay, this is how we do the voltage analysis in simple circuit. Next question. Okay, before going into next question, these are the few examples of the students who were able to do the circuit analysis properly and got a beautiful rank in KCET, and they are all from our Diksha offline campuses. So if you want to study into our Diksha offline campuses, or if you want to recommend any of your neighbors, friends, family, then definitely there is a link given in the description of this video. You can go there, click there and register the form. Our representatives will contact you for any future detail. Right, let's move on to the next question. for a given electric current, the drift velocity of a conduction electron in a copper wire is Vd and their mobility is mu. Okay, when the current is increased at a constant temperature, so current is increased at a constant temperature, so current is NEA Vd. So obviously NEA is assumed to be constant, right? Because it's a uniform wire, if nothing is provided, you have to assume that this is an uniform wire. So A is constant, N and E is obviously constant. That means if you increase I, the drift velocity will also increase. So if you increase current, drift velocity will also increase. But what is mobility? Mobility is drift velocity by electric field. Drift velocity by electric field. Now if you increase current, electric field will also increase. Okay, and only way to increase current is by increasing the electric field. Electric field and current are actually proportional. Current density, remember, current density J is equal to sigma E. So current and electric field are proportional. So that means the amount by which you increase the electric field, by the same amount the drift velocity will also increase. So mobility will remain unchanged. In fact, mobility depends only on temperature. Mobility's actual expression depends on the relaxation time. The relaxation time is constant for a given temperature. Okay, it is basically mobility is inversely proportional to relaxation time. Okay, if you increase the temperature, relaxation time decreases and mobility also mobility increases. In case you decrease the temperature, relaxation time increases, mobility decreases. Okay, that is how it works. So Vd increases, mu remains same. Vd increases, mu remains same. 10 identical cells, each EMF 2 volt and internal resistance 1 ohm are connected in series with 2 cells wrongly connected. Actually it should have mentioned that out of them 2 are wrongly connected. So that means we had 10 cells, right? 10 cells each of 1 volt. 10 cells each of 2 volt and 1 ohm. Okay, 1 ohm is the internal resistance, 2 volt is the potential difference, right? So this is what given. Now it is said that they are all connected in series. If they are properly connected, 10 into 20 would have been the proper voltage, but it mentioned that 2 of them are wrongly connected. Wrongly connected means what? Wrongly, how can you connect wrongly? So if you connect them in series, that means if you suppose this is our normal flow, if you connect wrongly, that means they are connected in opposite polarity. They are connected in opposite polarity. Okay, so 8 such cells are properly connected, but 2 of them are connected in the opposite polarity. 2 of them are connected in opposite polarity. So how many of them are properly connected? 8 of them, right? How many of them are wrongly connected? 2 of them. And what is the meaning of wrongly connected? That means they are connected in opposite polarity. So opposite polarity means what? They are reducing the voltage. So 8 minus 2. So this is the number of cells they are properly connected in a single direction. So what is the actual equivalent EMF? Actual equivalent EMF is the equivalent number of cells times the voltage of each of them. So that will be 6 into 2, that is 12 volt. So 12 volt is the actual EMF of the circuit. That is the main problem. Rest is very easy. Okay. So what is the current going through now? No matter if you connect them properly or improperly, resistance will always be added. Resistance will always be added. That is the main question. So resistance equivalent is 10 of the battery, each of them has 1 ohm, so it will be 10 ohm. So 10 ohm is the resistance. So what is the current in the circuit? Current will be Now external resistance is 10 ohm. External resistance is 10 ohm. So current is basically epsilon divided by R equivalent plus R, right? So epsilon is 12 volt and R equivalent is 10 and also capital R is 10, so it will be 12 divided by 20, that is 0.6 ampere. 0.6 ampere, so correct answer is this. Now this is the KCET 2023 question. The equivalent resistance between points A and B in the following circuit is. The equivalent resistance between A and B in the following circuit. This type of circuits are called infinite circuit. Now in case of infinite circuit, you have to understand that the equivalent resistance, if you just remove one or two resistance from the front of the part, the total equivalent resistance does not change. Okay, so for example, if you see this circuit like this, and if I hide this part, this first three resistances, if I hide this part, okay, the overall structure looks same, right? Because it goes to infinity, so even if I remove these three resistances, the equivalent resistance does not change. So if you measure the equivalent resistance between A and B, or you measure the equivalent resistance between say C and D, the equivalent resistance remains same. So what we can say that, suppose the equivalent resistance is given by capital R, and we remove the three resistances from the first, so remaining part will also have same equivalent resistance R. So this is the trick. This is the one and only trick to solve such question. So you have to find the pattern, the repetition point. You have to find the repetition point. So if you see that repetition point means it has a U shape over here. So if you remove this part, it will also have the same U shape. Okay, it will have the same U shape. So you remove the minimum possible resistance to get the repetition pattern. This is called repetition pattern. So this structure is getting repeated again and again up to infinity. Okay, so you have to remove first minimum possible repetition part, and then say this is 2 ohm we know, this is 2 ohm we know, this is also 2 ohm we know, and here you connect that whatever part you have removed, this portion, you say this one will also have equivalent resistance R. Now you connect that repetition part as with the total resistance R, right? Now interesting part is that the equivalent resistance of this circuit is also R. Why? Because this is part of the original circuit, we only removed it. Then even if you add them back again, or suppose we add 3 more resistance over here, will the resistance, total resistance change? It will not change. This is an infinite circuit. Does not matter if you add or remove the 3 resistances, right? So this circuit will also have the same equivalent resistance as R. Now you have to solve it. So these two and these R is in parallel combination. So in parallel combination, what is the equivalent resistance? Parallel combination equivalent resistance will be 2 into R divided by 2 plus R. So this will be 2 R by 2 plus R. Parallel combination, R1 R2 by R1 plus R2. Now this is, all these 3 resistances are in series. So what is the value? 2 plus 2 plus 2R by 2 plus R, right? Now what is the equivalent value of the equivalent resistance? That is also R. So this is the trick. This is the one and only trick to solve such equation. So if you remove this portion and then if say okay, this will also have the same resistance, so that means equivalent resistance and the portion that you remove, they are all coming in the same equation. This is a very old trick in the book. So R equals to 4 plus 2R divided by 2 plus R, or R minus 4 equals to 2R by 2 plus R. So you will get a quadratic equation, then you have to solve it. Okay, that is the only pain in this question. 2R minus 2 into R is 2R, 2 into minus 4 is 8, R into R is R square, minus R into 4 is 4R equals to 2R. Okay, 2R cancels. same values, that's why I cancelled it, and you get this as r square minus 4r minus 8 equals to 0. Now this you cannot just simplify it using normal method, right? Factorization is not possible, so you have to use the quadratic equation. So r equals to minus b means 4 plus or minus. Now plus or minus value we will ignore, resistance cannot be negative, so we only need to consider the plus value. B square minus 4ac, b square means minus 4 square, that is 16, minus 4ac means minus 4 into 1 into minus 8, that is plus 32. Okay, if you are not familiar with quadratic equation solution, you have to go and solve few more in your mathematics class. Divided by 2a, so divided by 2, a is 1 over here, right? So you will get 4 plus 16 plus 32 is 48. 48 means 16 into 3, that is 4 root 3 by 2, or you get this as 2 into 1 plus root 3. Okay, so this is the value of the resistance. Now none of the values are given like this, so you have to simplify it a little bit more. So 2 into 1 plus 1.73, so that will be 2 into 2.7, which will 73 actually, so you will get 2 to the 4, 14, 46, so it will be 5.46. okay, 5.46 means closest value is 5.5. Now this is an irrational number, so it goes on, the decimal goes on, so you can without using calculator, this is the only way to solve. Okay, 2.5 into 2 is 5, 2.7 into 5 is 5.4, so 5.4 if you arrive it, that is also fine. 5.4 means closest value will be 5.5. okay, now next, a wire of resistance R is connected across a cell of EMF epsilon and internal resistance R. Now not all the questions are this lengthy, not all the questions are this difficult. Every year at least one question is slightly difficult or tricky, maybe 1 or 2 questions are slightly conceptually important, and rest of the questions are easy. Okay, 3 questions generally you get easy from this chapter. A wire of resistance capital R is connected across a cell of EMF epsilon and internal resistance R. So as you can see, a lot of questions are coming from cell geometry only. The current through the circuit is I. In time t, the work done by the battery to establish the current I is. This is easy question. To establish the current I means what is the energy that is dissipated? Energy dissipated is I square RT. It does not depend on the battery that you connect. It only depends on the current and the resistance and the time. So from that we say this is the correct answer, I square RT. 10 identical cells each of potential E and internal resistance R are connected in series to form closed circuit in an ideal voltmeter connected across 3 cells. We solved it during our lecture. I think I will solve it once more. So here we have 10 cells, each of them are connected in series. So they love 10 cells. We have seen one 10 cell problem, this is another 10 cell problem. So 10 of them are connected in series. So what is the total voltage? 10 into the EMF, that is 10, EMF is given E. So 10 E is the total EMF. What is the total resistance? So this is the equivalent. What is the equivalent resistance? Equivalent resistance is 10 into R. So what is the current? Current is nothing, no external resistance is connected over here. If you see, no external resistance is connected, so current will be simply E by R. Now how many cells across which you have connected the voltmeter? You have connected across 3 cells. Okay, so that means what is the resistance? Now cells generally will not have any roles here, so resistance, how many resistances are there? 3R. Current is I. Okay, so 3R into the current, that is 3R into E by R, that is RR cancels, you get 3. Okay, So 3 is the correct answer. Here I made small mistake. The current will be in this direction. Okay, positive, negative, small mistake I made. Anyway, let's move on to the next question. Easy question. This is an easy question. In an atom, electron revolve around the nucleus along a path of radius 0.72 angstrom, making 9.4 into 10 to the power of 18 revolution per second. The equivalent current in this case is given by. Now, very interesting question. So first of all, you have to understand that this information is not required. There will be some information which is not required. So one electron is revolving this many times per second. So what is the charge? What is the charge? That is very important. Per second. Per second means Q by T. Already given to you. So what is Q by T? Number of turns, number of rotations times the charge of an electron. Okay, so the same electron is rotating. So if you construct a surface area over here, then you will see that per second this much charge is passing. This much charge is passing through this cross section. That means this is the current. This is the current over here. So number of revolution is 9.4 into 10 to the power of 18, and charge of an electron is 1.6 into 10 to the power of minus 19. So it will be 9.4 into 1.6 into 10 to the power of minus 1. Now how to multiply these two values? Okay, either you can try and multiply them mathematically, normal way, or there is a smarter way. I will teach you the smarter way. Convert 9.4 into 10. And if you multiply this with 1.6, what you will get? You will get 1.6. Okay, now 99% cases this approximation is accurate. Okay, and you can even answer the question by just looking by this value. But for this particular question, it is slightly tricky, because if you see, all the values are very close. Even if they have not given 1.6 directly in the option, but all the values are very close. If it is given like 1.5, 2.4, 3.2, 8.8, then you would have identified, okay, 1.5 might be the answer. But in this case, it is slightly difficult for you to identify 1.5 is the answer. You might think 1.4 or 1.5. So obviously, you have to take the closest number to this value. The closest number to this value is 1.5 and not 1.4. Okay, the closest value is 1.5 and not 1.4. So you can safely answer 1.5 as your answer. Okay, in case they also give 1.6 as the option, in that case you have to remember that what you have done, you have approximated 9.4 to 10, right? What is your approximation? You approximated key 9.4. I am assuming that value is closer to 10, right? That means you have increased the number. You have increased the number. So if you increase the number, that means your result, whatever result you are getting, that is also increased. So actual value or the actual calculated value should be less than this 1.6. Which number is less than this number? 1.5. Okay, this is also a way to calculate. This is also a way to approximate. So these are the small approximation methods that you have to develop over next 6, 7, 8 months. When a metal conductor connected to left gap of meter bridge. Now, oh, sorry, this question I forgot to delete. Meter bridge is not part of the syllabus. Sorry, my mistake. A charged particle is moving in an electric field of E equals to 3 into 10 to the power of minus 10 volt per meter with mobility 2.5 into 10 to the power of 6 meter square per volt second. The drift velocity is. So we know that mobility is drift velocity divided by the electric field. So drift velocity must be equals to mobility into electric field. Okay, mobility is given 2.5 into 10 to the power of 6 and electric field is given 3 into 10 to the power of minus 10. Okay, 3 into 10 to the power minus 10, so it will be 7.5 into 10 to the power of minus 4. Okay, so correct answer is 7.5 into 10 to the power of minus 4. So this is the correct answer for this question. Next question. A voltage across a bulb rated 220 volt 100 watt drops by 2.5%. If it is rated value, then the percentage of the rated value by which the power would decrease. Now I solved this question during my lecture. For that you have to understand that power is basically V square by R. Now why we are choosing this equation? Because for a particular bulb the resistance remains constant. So this is why we are choosing it. So P and V relation is P is directly proportional to V square. That is why we are choosing this relation. Okay. Now also dP by P will be 2 dV by V. Okay. You can check this out. This is a differential equation. You just need to do it, differentiate it and divide it by the terms and you will get this value. Okay, how to do that? Find dP by dV, which is equals to 2V. So dP equals to 2V dV. Right, now divide this side by P and this, so 2V by R, sorry, there is one R, my mistake. Okay. So 2V by R over here and then divide by P, and on the right hand side instead of writing P you have to write the value of P, that is V square by R, and if you do that you will get this equation, exactly this equation. Okay. Now this represents the change in percentage of the power and this represents the change in the percentage of the voltage. So if voltage drops by 2.5%, then the power will change by 2 into 2.5%, that is 5%. So voltage power change by only 5%, not 20, not 10, not 2.5, but 5%. A wire of a certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes respectively. Okay. Now you have to understand that specific resistance means resistivity. Specific resistance means resistivity. It's another name for resistivity. Specific resistance will always remain same. Specific resistance will always remain same, but the resistance will change. Now if you remember, what is the R new value? R new is the factor square divided by R old. Right? This was the formula I told you. Now in this case factor is not directly given, it is given, it is stretched by 10%. Stretched means increased. So what is the factor here? So initial length was 1, then the final length will be 1.1. 10% increase means 0.1 increase in the value. If length was 1 meter, new length will be 1.1 meter. As simple as that. So factor is basically 1.1 over here. So R new will be 1.1 whole square into R old, that is 1.21 R old. So resistance increased by 1.21 times, and the specific resistance, which depends only on temperature and the material, will remain same. So specific resistance will remain same, but the resistance will increase by 1.21 times. A wire of resistance 3 ohm is stretched twice to its original length, then the resistance of the new wire. Again same formula, I think it came 1 year previous than that other one. So R old, so R new will be F square times R old. What is F over here? Twice means 2 is the factor. F represents factor by how much time it increase, right? So F is the factor. So 2 square into old is 3, so 4 into 3, that is 12. Okay, for those who are wondering how I am solving it, for that you have to go back to my lecture where I discussed this formula particularly. A copper wire of length 1 meter and uniform cross-sectional area 5 into 10 to the power of minus 7 meter square carries a current of 1 ampere. Assuming that there are 8 into 10 to the power of 28 free electrons per meter cube in copper, how long will an electron take to drift from one end of the wire to the other? So let's see. This is a question of drift velocity, also gives you an idea how slow is drift velocity. Okay, so uniform cross-sectional area is given. Five into 10 to the power of minus 7. Current is given 1 ampere. Eight into 10 to the power 28 free electrons, number density per unit volume. How long the electron will take? So we know that I equals to NEA VD. So 1 equals to number density is 8 into 10 to the power of 28. E is 1.6 into 10 to the power of minus 19. Area is 5 into 10 to the power of minus 7 and VD. Okay, so VD will be equals to 5 into 1.6 is 8, 8 into 8 is 64, so 1 by 64, 10 to the power of minus 19 minus 7 is minus 26, minus 26 plus 28 is 10 to the power of 2, so it will be VD will be equals to 6400, 1 by 6400. Everything will come to this side and it will be 6400. Or you can simplify one more line over here. How I multiplied? 1.6 into 5. 1.6 into 5. 5 16s are 80. Okay, 5 16s are 80. So that means 1.6 means it will be 8.0. That is 8. So 8 8s are 64. 64 I have written. Now 28. Minus 26, 28 minus 26 is 2, so 10 to the power of 2, so 6400, so 1 by 6400. Okay, so these are the analytical skills. Again I am telling you, you have to develop it over time. Does not come in one day, but if you want to challenge KCET, then definitely you have to develop it. Okay, now length of the wire is given 1 meter. Length of the wire is given 1 meter. So if the time taken by it to reach from one side to another, say t second, then drift velocity will be 1 meter divided by t second. Right? Velocity is velocity. Distance traveled by time. So distance traveled is 1 meter. Time is t. So t will be equals to 1 by Vd. Now 1 by Vd means 1 by 6400. That is 6400 seconds. Okay, so 6.4 into 10 to the power of 3 seconds. 6.4 into 10 to the power of 3 seconds. So option D is correct. Next question. Let's see. A metal rod of length 10 centimeter and rectangular cross section of 1 centimeter into half centimeter is connected to a battery across opposite faces. The resistance will be, so let's see, so 10 centimeter length, okay, 1 centimeter of 1 centimeter width and half centimeter of height, right? So this is how the wire looks like. Okay, this is how the wire looks like. Now you are connecting battery. Either you can connect battery like this or like this, or from that side to this side. Okay, now let's see. The resistance will be maximum. Now which case resistance will be maximum. Resistance will be maximum when the length that it has to travel will be maximum. Okay, so if you connect the battery across these two faces, the length it has to cover is maximum. But if you connect the battery like this way, the length that it has to travel is the minimum value. Okay, so length maximum means resistance maximum. Resistance is proportional to the length of the conductor. It does not depend on the area, it depends on the area also, but inversely proportional to area. So area should be smaller. Should be smaller, length will be bigger for maximum resistance. So in this case you see that these two are the smallest areas, right? These two are the smallest areas, and this is also the longest length. So this is the sides where we want to connect. Okay, maximum when the battery is connected across 1 centimeter times half centimeter faces. 1 centimeter times half centimeter faces. You can read the question, understand it once more, what the question talks about. Okay, slightly language wise tricky, but question is very simple. Identify that in which case length is maximum, area is minimum. That's it. Okay, so if you see this case where area is minimum, length is maximum, the resistance will be maximum. If same question is asked, this is a homework question. If same question is asked, in which case the resistance will be minimum, in which case resistance will be minimum, mention the answer in the comment below. So minimum resistance when the resistance will be minimum. A car has a fresh storage of battery of EMF 12 volt and internal resistance 2 into 10 to the power of minus 2 ohm. If the starter motor draws a current of 80 ampere, then the terminal voltage of the starter motor, again we solve this question. It is basically E minus IR. Okay, epsilon is given by 12 volt, I is 80 ampere, the resistance is 2 into 10 to the power of minus 2, that is 160, 1.6, so 12 minus 1.6, that is 10.4 volt. 10.4 volt is the correct answer. Next question. Each resistance in the given cubical network has a resistance of 1 ohm and equivalent resistance between A and B. So this is a very interesting question. This is a cube. Okay, each arm has 1 ohm resistance. Okay, now for that, first of all you have to understand this is a symmetric circuit. That is the major part that you have to understand. Suppose if I send say 3I current, how much current? 3I current through this cube. Okay, then when the current reaches at this particular point, okay, how many paths it has? It has 3 paths, one this, and another this. Now will the current distribute equally? Will the current distribute equally? So for that, to understand that, you have to understand this point, that if suppose a current is passing and you find a path, 3 path or 4 path or 5 path, will the current always distribute equally? No. But when the current will distribute equally? The current will distribute equally if all the resistance are same. If the paths offer equal resistance when the current is flowing from one side to another, then if you apply say 3I current over here, then they all will be distributed equally. The current will be distributed equally only when the all possible paths are equally resistive. It is called equally resistive. Now if this circuit is equally resistive or not, that we have to check. Now first, obviously you might think, sir, all the resistances are 1 ohm, so must be equally resistive. You are correct, but also you are wrong. So if you go from here, current is not exiting from this end, current is exiting from this end. So you have to check all smallest possible resistive paths. Smallest possible resistive path means you are starting from here, Okay, you are going here. So how many resistances you are occurring? 1 resistance, 2 resistance, 3 resistance. 3 are here, 1 resistance, 2 resistance, again 3 resistance. Okay, this is the minimum possible path. Now from this 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So all possible paths that leads from here to here, from A to B, they all have 3R resistance. So this is an equiresistive circuit. All paths are equiresistive. That means if you send 3I current, all the currents will be distributed equally, I here, I here, I here. So that is why I have chosen the current to be 3I, nothing else. Okay. Now, so this part is done. This is Kirchhoff, and this is nothing but Kirchhoff's current law, Kirchhoff's current law or Kirchhoff's junction rule. Now this current started here. Okay, this current started here. Now when it reaches this junction, this is the junction 1, this is junction 2. Now again at this junction it will have 2 paths, one along this, one along this, right? And both paths are equiresistive, as I said. So equiresistive means current will be distributed equally. For equiresistive path, current will be distributed equally. So I current is getting in, so the current output will be I by 2 and I by 2, so that when you add them back you get the old current back, right? So this is simple. Now we don't need to do anything else. This is sufficient. Now once all the currents reach over here from all the direction, again the current which is going in should also be I, so that the exit current should also be 3I. That is the conservation of charge, right? Whatever current going in, the same current should go out. So again I by 2, from here I by 2, okay, I by 2 plus I by 2 is I by 2 from here, I by 2 from here, they will get up I. So that's how you are getting I. So this is how you solve this. This is a very specific circuit. Okay, now what you have to do, you can consider everything, or simply you just need to take 3I. This was our I, okay, this was our I by 2, and this is again I. Only 3 resistance we will consider in our journey. Remaining all the resistance we will ignore for now. Okay, our target is to find the equivalent resistance. Equivalent resistance. Now if you apply say a V volt power supply in this cube, what is the current? Current is 3I. Now let us apply Kirchhoff's voltage law, and to apply Kirchhoff's voltage law, as I said, we need to construct a loop. So what is the loop? You start here, you go over here, you pass through the arrow mark route, and then again you come back over here. This is a closed loop, right? Closed loop means we can apply Kirchhoff's voltage law. So what is the, suppose this every resistance is R. For now I am assuming every resistance is R, not 1 ohm. Okay. So what is the voltage drop across this resistance? Voltage drop across this resistance is I into resistance, IR. What is voltage drop across this resistance? Again I into R. Now in this case I is I by 2, right? And for this resistance, again I into R, right? And from Kirchhoff's voltage law, this must be equals to the supplied voltage, right? So what is the value? You will get this 2R plus half, that is 5 by 2 IR equals to V. 5 by 2 IR equals to V. Now what is the equivalent resistance of this entire thing? So if you draw the equivalent circuit, voltage supplied V, current in the circuit, not I but 3I, current in the circuit is 3I. So from this we can write R equivalent is nothing but V divided by 3I, V divided by 3I. Now what is V? V is 5 by 2 IR divided by 3I, I cancels, you get 5 by 6 R. So R equivalent is 5 by 6 into 1 ohm, that is 5 by 6 ohm. Okay, so correct answer is this. Now this is a common template, common formula. You can remember this as a formula as well. If the same question is asked to you with 2 ohm, 5 ohm, 10 ohm, 20 ohm, 12 ohm, you just need to change the R value and you can calculate the equivalent resistance in just less than 1 second. Okay, maybe 10 seconds. Okay, so you have to remember this value. If you remember, this is a very particular circuit. This exact question is solved in your NCERT as well, and this question came only once in the KCET 2020 only. I have not seen this question in the past. There is a less chance of repeating, but they might ask the same question with a different value. That is possible. Okay, in that case you just need to multiply 5 by 6 with R. Okay, derivation or the solution I have done in detail. So those who wanted to understand this question I explained, those who just wanted to the solution using formula, that also I have done. Now IV characteristics of the copper wire of length L and area of cross section A is shown in the figure. The slope of the curve becomes so this is a I versus V graph. I versus V graph means what? We have already understood that. What is the slope? So this is theta. So slope tan theta is basically I by V, Y by X. So this is the tan theta. So this is the slope. Now slope is basically 1 by R. Slope is 1 by R. I by V means 1 by R. Right? Now what will happen to the slope if area of the wire is increased? If the area of the wire is increased, R equals to 1 rho L by A. So this will be A by rho L. So slope is basically exactly opposite of the resistance. So if you if you increase the area, the slope will also increase. The slope will also increase. So this is not the correct statement. If you increase the area, slope will also increase, less if the length of the wire is increased. If you increase the length, then the slope decreased. If you increase the length, then the slope decreased, not increased. So less if the length of the wire is increased. Yes, this is correct. Less if length of the wire is increased. So if you increase the length, the slope decreases. So definitely option B is correct. Let's check the other options. More if experiment is performed at higher temperature. If you perform the experiment at higher temperature, then rho increases. So rho increases means tan theta decreases, slope decreases. More if a wire of steel of the same dimension is used. So if you are using steel, steel has higher resistivity than copper. So higher resistivity of copper means slope decreases. The slope will only increase when the resistance decreases. That is the basic fundamental of this question. The slope will only increase if resistance decreases, and vice versa. That means resistance increase in resistance means slope decreasing, decrease in resistance means slope increasing. So here if you increase the length, resistance increase, slope decrease. Okay, the language, again this is a language question, not very theoretical question. Through the electron drift velocity, though the electron drift velocity is small, and electron charge is very small, a conductor can carry an appreciably large current. So why a conductor can carry a large current even though the drift velocity is small, the area of the conductor is very small, but still the conductor can carry a large current because of this value, because of this number density. If you have seen one question, number density is of the order of 10 to the power of 28, right? So electron number density is very high, electron number density is very large. Okay, masses of 3 wires of copper are in the ratio 1:3:5 and their lengths are in the ratio 5:3:1. The ratio of their electrical resistances are. Now this is the little complicated question. I am not going to solve this question in this lecture. I will leave this as a homework. Okay, complicated question, obviously, that's why I am giving you as homework. This question, this type of question repeating in KCET is slightly less chance, but similar question has come in JEE. This similar question has come in Comet K as well, but there is a very less chance of this question is coming in KCET exam. Okay, but I am not discouraging you. You can solve this question and mention the question answer in the comment. In the given circuit, the current through the 2 ohm resistance. Now if you see, there is only one 2 ohm resistance, which is this one. Okay, there is only one 2 ohm resistance, which is this one. Now if you see the circuit carefully, here we have 1 ohm, okay, 2 ohm, and there are bunch of resistances parallel. This resistance and this is nothing but parallel resistance. Okay, if you see this kind of structure, you can simply reorient this resistance like this. So this is also a parallel resistance, this is also parallel resistance. Okay, so they are all parallel, bunch of resistance parallel to this zero resistance, and there are some in between resistance as well. Again, you can add these two resistances, and then this is parallel to this, and then you can add that, so that will be parallel to their equivalent resistance. Whatever equivalent resistance will be, that is parallel to zero resistance. If you see this kind of circuit where a few resistances are connected to a zero resistance, this is a zero resistance, straight line means zero resistance, then you can simply ignore these resistances. You can simply ignore these resistances, they will not have any effect, and only you need to consider this straight line. So that means in this given question, you can simply ignore this one, ignore this one, this one, this one, this one, and this one. Okay, because as I said, this entire combination is parallel to this zero resistance, so this will also have no effect in this particular circuit. So only resistance which is effective is 1 ohm and this 2 ohm. The remaining resistances will not play any role in this circuit. That is a very conceptual thing. Also, one more principle in that, current always tries to flow through a least resistive path. Okay, current will always try to flow through least resistive path. Okay, that means it will flow through a path where resistance is the smallest. So if you see that this path is the smallest resistive path, any other path it will take, it will always have higher resistance. So this is why the current will pass through this directly, and it will ignore all other resistances. Okay, so what is the total resistance in this case? Total resistance is nothing but 1 plus 2, that is 3 ohm. Okay, and what is the current? Now current in this case, 1 ohm, 2 ohm, both resistor have the same current. Okay, so the current in this case is 1.2 divided by 3, that is 0.4 ampere. 0.4 ampere. So this type of question is a fool question, where the examiner is trying to fool you. Now last question of the day, Kirchhoff's junction rule is a reflection of conservation of momentum, conservation of current density vector, conservation of charges, conservation of energy. Now what is the rule? Junction rule. For junction rule, it is charge or energy? It is charge. Junction rule is charge, voltage rule is energy. Okay, loop rule is energy. Okay, I hope you enjoyed this session, and if you want to feature in this picture like with us in future, then definitely what you have to do, you have to study hard, get a good rank in your KCET exam and meet us in our office. So for that you have to start today, and obviously you have to subscribe to our channel if you have not yet, and also join our WhatsApp channel. The link of that is given in the description. I will be back with the previous year question from JEE from this chapter. Till then, bye.